Okay guys, so this is going to be solving more complex trig equations, your example problems for this section. In this section, we're just going to be dealing with radians. If you deal with degrees, there's one extra step in there. And I'll show you what that extra step is in just a second. So this is going to be non-calculator for the most part, because most of these are on your trig charts. So just keep that in mind. So your steps are the same. Now, if we're looking at these trig equations, your angles are something other than just theta or x, okay? So they're a little more complicated. So we have to add a little extra step in there. So your first step is to identify your quadrants. So sine is going to be positive in quadrant 1 and quadrant 2. Your reference angle, you ask yourself, where is sine equal to 1/2? Well, it's equal to 1/2 at pi over 6. Okay, so a quadrant 1 answer is going to be pi over 6. Quadrant 2 answer is going to be pi minus pi over 6, which is going to be 5 pi over 6. Now, watch what I do right here. I have to put a plus 2 pi in. A plus 2 pi in. Okay, so I have to take care of any coterminal angles in there. If you're in degrees, this step would be 360 in and 360 in, okay? So once I do that, I set it equal to what my angle is equal to, 2 theta and 2 theta, like that. Now the whole goal is to solve for theta, so we're going to solve for theta. So to solve for theta, we're going to divide everything through by 2. Okay, so theta comes out to be pi over 12 plus pi n, and theta comes out to be 5 pi over 12 plus pi n. Now, it says we want to get all answers in between 0 and 2 pi. So n just means what revolution on the circles you're going. So, 1 circle, 2 circle, 3 circle, 4 circle, that sort of thing. Okay, so n is equal to 0. Let's do n is equal to 0 first. If I plug in a 0, it's pi over 12 and 5 pi over 12, so those both work. Okay, for n is equal to 1. So if n is equal to 1, we're going to do around the world. So this would be 13 pi over 12. If n is equal to 1 right here, you get 17 pi over 12. Now anything over 24 pi over 12 is going to be out of range, so keep that in mind. So if I do n is equal to 2, you would get 25 pi over 12. So these are your only answers. Okay, so that's all there is to this problem. Pretty much the same exact steps. Okay, next one. Okay, so tangent is positive in quadrant 1 and quadrant 3. Your alpha is going to be pi over 4. So tangent is equal to 1 at pi over 4. Okay, so we get a quadrant 1 answer is pi over 4, and a quadrant 3 answer is going to be 5 pi over 4. Now, we're going to add our 2 pi n step in there, plus 2 pi n, and that's equal to theta minus pi over 2. It's equal to theta minus pi over 2. Okay, so our whole goal is to solve for theta, so we're going to add pi over 2 to both sides. Okay, so theta is equal to pi over 2 plus pi over 4 is 3 pi over 4 plus 2 pi n. And I get theta is equal to 5 pi over 4. That comes out to be what, 7 pi over 4? If I add pi over 2, that's 4. Yeah, it should be 7 pi over 4 plus 2 pi n. Now we can only have answers in between 0 and 2 pi. So I'm going to say n is equal to 0. That cancels out that term. So you get 3 pi over 4 and 7 pi over 4. N is equal to 1. That's a 2 pi. So these are all going to be over the range. So these are your only two answers right there. Okay, next question. So secant is negative in quadrant 2 and quadrant 3. Okay, your reference angle should be pi over 3. Secant is equal to 2 at pi over 3. Okay, so quadrant 2 answer is going to be 2 pi over 3. Quadrant 3 answer is going to be 4 pi over 3. And that follows your pi plus alpha, pi minus alpha stuff. Plus 2 pi n, plus 2 pi n. We set that equal to our angle. Okay, so to get rid of 3/2, we're going to multiply both sides by 2/3. Okay, so we have to multiply everything through by 2/3. Okay, so we get theta is equal to, that's going to be 4 pi over 9 plus 4 pi over 3 n, and then we get theta is equal to, that's going to be 8 pi over 9 plus 4 pi over 3. And like that. Okay, so these fractions kind of get a little annoying after a while. So for n is equal to 0, this term goes away. So it's just going to be 4 pi over n and 8 pi over 9. Sorry, 4 pi over 9, 8 pi over 9. For n is equal to 1. Okay, so for n is equal to 1, if we're doing common denominator stuff, okay, we can't, so we're going to be in ninths, so we can't go past 18 pi over 9. Okay, so this is 12 pi plus 4 pi. So 12 plus 4 is 16 pi over 9. Okay, this is 12 pi over 3. So 12 pi plus 8 pi is going to be 20 pi over 9, which is out of our range. So these are our only answers that fall into this range right here. Okay, and I know the fractions are a little iffy on this stuff, but it's life, we have to deal with it. Okay, last example problem. So we are going to say, where's cosine negative? Cosine's negative in quadrant 2 and quadrant 3. Cosine is equal to 1 at 0. So it's pi for both of them. Okay, so we only really have one answer for this. Okay, so there's no use to doing that over again. So our only answer for this is pi. And if you wanted to take the shortcut, you could say that where's the x coordinate equal to a negative 1? It's pi, okay? Plus 2 pi n is equal to 2 theta minus pi over 2. Okay, so we're going to solve for theta. We're going to add the pi over 2 to this side, so we get 3 pi over 2 plus 2 pi n is equal to 2 theta. And then we have to divide both sides by 2. So we get 3 pi over 4 plus pi n is equal to theta. Now we have to do our n is equal to 0. So for n is equal to 0, we get 3 pi over 4. N is equal to 1. We should get 7 pi over 4. N is equal to 2. Gives us 11 pi over 4, which is greater than 2 pi. Okay, so we can't go past 8 pi over 4. So these are your two answers for this equation. So when you're doing this, make sure you don't forget the plus 2 pi n step. If we're in degrees, this would be plus 360. And make sure you check your interval to see where your answers should fall. So all these answers should fall in between 0 and 2 pi. If you wanted to work this in the calculator, you could work in the calculator. It still work the same exact way. You still have to find a reference angle the way we learned in the previous lesson. The reason we're using the trig chart on this and not the calculator is because all these values end up on your trig chart. So this has been solving more complex trig equations. If you have any questions, feel free to reach out, and have a good afternoon.